For the reaction x plus 2y is giving z, 5 moles of x and 9 moles of y will produce. Now in this case, if you will find the 1 mole of x is reacting with the 2 moles of y. They have given us the 5 moles of x. If I take 5 moles of x, we need 10 moles of y in this reaction. But they have given us only 9 mole of the y. Therefore, the reaction is limiting with respect to y. Whatever is the y present, only that much amount of reaction will take place. So if you have 9 moles of y, the half of the moles of the z will be obtained. So it's around 4.5. Therefore, option is D, 4 moles of z will be obtained. Question number 47. The formula mass of the Mohr salt is 392. The iron present in its oxidized by the KMnO4 in acid medium. The equivalent mass of the Mohr salt we need to find. First of all, the Mohr salt is ammonium sulfate, FeSO4, 6 of H2O, which contains only one Fe. When Fe is oxidized, Fe2 plus is oxidized with this KMnO4 solution, it is getting converted into Fe3 plus, where Mn itself will become Mn plus 2. This will happen in acidic medium definitely. Now in this case, the change in oxidation state of Fe is only plus 1, that is difference of 1 electron. So if I have to calculate the equivalent mass of the Mohr salt, I need to divide it by 1. Molecular weight of the Mohr salt is 392. So if I divide it by 1, so I'll get the same answer. Therefore, option A. Question number 48. The wave nature of electron was demonstrated by. The wave nature was demonstrated by the de Broglie, who has actually given the dual nature of the wave, that is electrons also. Therefore, option B. Question number 49. Which of the following is non-permissible? Now we need to find according to the rules. If we'll see the option A, n is equals to 4. So L value is permissible because L can have value from 0 to n minus 1. So it is in the permissible range of the given n, and M can have value 0. So this set is permissible. Option B, if n is 4, the L can have value from 0 to 3 again. So it is permissible. Option C, n is 4, L is 4. This is not permissible because our formula is 0 to n minus 1. So it should be in the range of 0 to 3. Therefore, option C is not permissible. Question number 50. Which is the correct order of the electronegativity between fluorine, nitrogen, oxygen and carbon? Amongst them, the highly electronegative is a fluorine, then nitrogen, then it is oxygen. This is oxygen first, and then it is nitrogen, and then less electronegative is definitely carbon. Now amongst this, if I am talking about the order which is given here, they have given N first. So fluorine, after that if I am writing nitrogen, the fluorine should be highest, and if after that if I am writing oxygen, then it should be lower. Nitrogen should be lower than oxygen and higher than carbon. Therefore, option A. Question number 51. The valence bond theory of the metallic bond was given by, the valence bond theory concept was given by the Pauling. Question number 52. In which of the following hydrogen bond is present? Hydrogen, ice, sulfur and hydrocarbon. So the hydrogen bond is present in definitely the ice, that is water. Then question number 53, the face-centered cubic cell atom, the face contributes, every face contributes the half part to the unit cell. Question number 54, for the following reaction, A plus B giving C, delta E is given and delta S is given to us. We need to find the value of delta G. Now in this case, first of all, we need to find delta H. So delta H is equals to delta E plus delta nRT. So that is equals to, delta is given is minus 5. This is plus delta N, if you'll find, this is one gaseous state, there are two gaseous states. So delta N will be minus 1 into R is 2 calories into 298. So if you'll calculate this, this comes out to be minus 601. Now we have an equation delta G is equals to delta H minus T delta S. Delta H is minus 601 minus temperature given is 298 into, this is minus 10 calories. Therefore the answer is 2379 calories. So option given are 26, 26, 26. Our answer is 23. So none of this. Question number 55. Carbon cannot reduce Fe2O3 to Fe at the temperature below 383 Kelvin. That is because about 390, that is 983 Kelvin, the free energy change for the formation of the carbon dioxide is more negative than that of the ferric oxide. Thus, above this temperature, carbon has the higher affinity towards the oxygen rather than the iron. So carbon itself will undergo the oxidation rather than it is reducing that particular Fe2O3. So free energy change for the formation of the carbon monoxide is more negative than that of Fe2O3. CO is thermodynamically more stable than Fe2O3. Carbon has affinity towards the oxygen than the iron. So option C. Question number 56. PCl5 is decomposed to PCl3 and Cl2. The initial concentration of each of reactant is 1 molar. If the K equilibrium is 0.41, then we need to find, first of all, for this equations, the Kc is the product divided by the reactant. We have the equation 0.41 value. So definitely that is equals to the product concentration divided by the reactant concentration. The answer is in the 0.41. Definitely the product concentration has to be less than the reactant concentration. Then only we'll get this particular value. Therefore, the reaction proceeds in the backward direction. Since the product concentration is less than the reactant, it is going in the backward direction. So more PCl5 will be formed in this reaction. Therefore, option C. Question number 57. The oxidation state of chromium in the final product formed by the reaction between the Ki and K2Cr2O7. So when this reaction occurs, the chromium from +6 changes to +3, while the iodine itself get liberated along with the water. Therefore, the +3 is the oxidation state obtained. 58. In which of the following reaction the hydrogen is acting as the oxidizing agent? With Li to form LiH, Li to form LiH. In this reaction, if you'll find hydrogen is 0 here, it is -1 in this case. In this case, the oxidation state of hydrogen is decreasing, and since it is decreasing, it undergoes the reduction. Therefore, definitely it is oxidizing agent. Question number 59. The equilibrium molecular structure of the hydrogen peroxide is planar as given below, linear, tetrahedral or non-molar. It is non-planar in nature because it's called as an open book structure. The soda lime is the combination of NaOH and calcium oxide, option B. 61. The carbon suboxide C3O2 has the particular structure. This is C3O2, it's nothing but O double bond C, double bond C, double bond C, double bond O. This is definitely having the linear structure, option C. Question number 62. Aluminium is obtained by reducing Al2O3 with coke, electrolyzing Al2O3, dissolving in cryolite, and reducing Al2O3 with the chromium, and option D, heating alumina with the cryolite. So electrolyzing is the better process for obtaining the aluminiums, therefore options B. Question number 63. During the nitration of the benzene, the attacking electrophile is. The nitration of benzene is an electrophilic substitution, therefore definitely the attacking reagent is NO2 plus. Hence option is C. Question number 64. The CH3CH2 double C triple bond CH on reaction with HgSO4 and H2SO4. This is carrying out for the hydrolysis of the reaction. This will give the hydrolysis product of the reactant. So we'll get CH3, CH2, then this will become OH, double bond CH2. The tautomerism will take place, double bond will shift here and the proton will be shifting here. So we are getting CH3, CH2, C double bond O, CH3. Therefore option A. Question number 65. The reaction of toluene with the chlorine in presence of the ferric chloride gives predominantly. Reaction of toluene, if you will carry out with the chlorine, this is the ortho and para directing group, so we'll get ortho and para chlorotoluene. Question number 66. Gas release during the Bhopal tragedy was, the gas release was the methyl isocyanate. Question number 67. The crystalline structure of the NaCl. NaCl has the FCC packing in which containing the 4Na plus and 4Cl minus. Each Na plus is surrounded by around 6Cl minus. So this is FCC packing, face centered, option B. Question number 68. The cubic structure of the diamond, which is made of the XY, where X is present at the corner. So corner, that means 8 into 1 by 8, that's equals to 1. And Y is present at the face center, 6 faces, each contributing half, so 3. So the formula of the compound is XY3, option D. Question number 69. The vapor pressure of the water at 20 degrees Celsius is 17.54 mm. When 20 gram of non-ionic substance is dissolved in 100 gram of water, the vapor pressure is lowered by 0.30 mm. What is the molecular mass of the substance? So we have a formula P0 minus PS upon P0, that's equals to the weight of a substance, that is solute, divided by its molecular weight multiplied by the weight of the solvent into the molecular weight of that particular solvent. So when I'm talking molecular weight of that particular solvent, so in this case P0 minus PS, the lowering of vapor pressure is 0.30. The water vapor pressure is 17.54. That's equals to weight of the solute is 20. Molecular weight of solvent is 18. Solute we need to calculate, and the weight of this thing is given is 100. So when you calculate this comes out to be 210.48. Therefore option C. Question number 70. Which of the following concentration unit is independent of temperature? Normality, molarity, molality and ppm. The answer is molality, because it is only depending on the weight, not the volume of the solution. Hence it is independent of the temperature. Question number 71. The specific conductance of 0.1 normal KCl solution at 23 degrees Celsius is 0.012 per ohm per centimeter. The resistance of the cell containing the solution at the same temperature was found to be 55 ohm. Cell constant we need to calculate. We have a formula, specific conduction, that is K is equals to 1 upon R into cell constant. Therefore cell constant is equals to K into R. K is given to us, that is 0.012, and the resistance is given to us, that is 55. So this comes out to be 0.66. Hence answer A. Question number 72. For the reaction between the gaseous compounds, twice of A plus B giving C plus D, the rate law is given to us. If the volume of the container is made 1/4 of the initial, then what will be the rate of reaction as compared to the initial rate? So if you are changing the volume container 1/4, it is reduced, definitely that concentration is increased by 4 times. And if the concentration is increased 4 times, 4 and 4, that will be 16 time increase compared to the initial rate. So 16 times, option A. Question number 73. RCl plus NaOH giving ROH plus NaCl. This is given by this rate law. The rate of this particular reaction is doubled by doubling the concentration of NaOH. It is independent of NaOH. It is not correct. It's half by reducing the concentration of RCl by 1/2. Yes, it is first order reaction. Therefore, it will change according to the concentration of RCl. Question number 74. The term catalyst was given by the Rutherford, Berzelius, Waller and the Colby. So it is Berzelius. Question number 75. The PB and TEN are extracted from their chief ore. PB and TEN are generally extracted by the carbon reduction, and the major process which can be used is self-reduction, because PbO and PbO4, SO4, they can be itself reduced by the PbS, which is already present in the mixture. Therefore, the process used is self-reduction and the carbon reduction. TEN is reduced by the carbon reduction and lead is reduced by the self-reduction. Cryolite is sodium aluminate fluoride. 77. Each of the following is true for the white and the red phosphorus, except they can be oxidized by the heating air. Yes. Are soluble in CS2? No. We have white phosphorus that is soluble in CS2, but the red is insoluble. So option B is incorrect. Brass is the alloy of copper. Brass is the alloy of copper with a zinc. Therefore option D. Question number 79. Which of the following is the colorless? When I'm talking about the colorless species, we have two options here, Cu2 plus and Cu plus. When I talk about Cu2 plus is 3D9 configuration and Cu plus is 3D10 configuration without any paired electrons, therefore unpaired electron, therefore option D is colorless. Question number 80. The type of magnetism exhibited by Mn H2O 2 plus. Over here Mn is in plus 2 state. So Mn plus 2 state, that means 3D5 configuration, and 3D5 configuration, if we'll talk, that is having 5 unpaired electrons. So definitely the magnetism is paramagnetism. Question number 81. CHCl3 allowed to react with HNO3. This will remove the proton from over here and it will be replaced by NO2. So we'll get formation of the chloropicrin. Therefore option A. Question number 82. The ether is more volatile than alcohol, having same molecular weight formula. This is due to the intermolecular hydrogen bonding in the alcohols. Definitely in the case of alcohols, hydrogen bondings are present which are absent in the case of ether. Therefore ether is more volatile. Question number 83. Picric acid is a stronger acid than the acetic acid. First of all, the picric acid is OH with the 3 NO2 group which are present. So it contains SO3H, 2SCOOH, phenolic group. It contains 3 NO2 groups. So this is 3 NO2 group present, because of that it is acidic in nature. Question number 84. The product obtained in the following reaction. If we'll heat this particular product, OH will be lost from here, H will be lost from here. So we'll get R, CH, double bond CH, COOH. Therefore option C. Question number 85. In the following reaction, conversion of cyanide to corresponding amine. This can be done by the reducing agent like lithium aluminium hydride. Question number 86. The name of the method which is used to separate primary, secondary and tertiary amine, it's called as Hoffman's method, in which the mixture of primary, secondary and tertiary amine is allowed to react with the diethyl oxalate, where the primary amine forms the solid oxamide, secondary forms the liquid oxamide, while the tertiary will not react. So we can distinguish between the primary, secondary and tertiary using the Hoffman's method. Question number 87. An example of the sulfur containing the amino acid out of this, it's cysteine. Cysteine is SH, CH2, CH, NH2 and COH. Definitely, so this is cysteine. Question number 88. Example of the natural biopolymer: Teflon, nylon 66, rubber, DNA. The option is DNA, biopolymer. 89. Pterylene is a polymer of. Pterylene is the combination of the ethylene glycol and the terephthalic acid. Option C. Which of the following gives the paracetamol on acetylation? The option D, because if I'll carry out the acetylation, it will give me product OH, NH, COCH3, which is paracetamol. Therefore option D.